Ladies and gentlemen, good morning. We are at a crucial point in the evolution of security, where AI and IoT are redefining the boundaries of physical and digital protection, particularly in critical sectors such as transport, energy, airports, and borders. The rise of hybrid threats and the growing sophistication of risks demand increasingly integrated, intelligent, and adaptable solutions. That is why we have here three international leaders who are driving this transformation. Peter Walhoefer from Rohde Schwarz was been focusing in micro-imaging and AI-based military wave security scanners. Adan Morik from SeeTrue, at the forefront of using artificial intelligence for automatic inspection and advanced analysis, and Daoíz Zamora from Mion Technologies, whose mission is to develop innovative sensors that are revelation security operations, especially in the detection of narcotics and explosives. This panel is an opportunity to discuss the real impact of AI and IoT, to understand how they can improve prevention and response to threats, and to explore how these innovations can address complex challenges such as precise detection of dangerous substances in critical environments. I will start our discussion with you, Peter. Rohde Schwarz has been at the forefront of innovation in the RF sensors in electronic security. Can you give us a brief explanation of these sensors and what are the role of AI playing in this evolution of these Rohde Schwarz solutions?
Yeah, thank you. Warm welcome from my side also. Yeah, physical security is always dealing with competitive ideas. On one hand, you want to maximize security. On the other hand, you don't want to bother 99.99% of the people who are harmless. And AI definitely helps us here to deal with these competitive requirements. So I think a good example is looking back in the aviation security, what happened. Until 9/11, walk-through metal detectors, manual frisking was the standard in aviation security. And quickly then it was recognized that, okay, explosives, liquids, non-metallic items, they cannot be detected with walk-through metal detectors, so we need something else. That was the time when X-ray backscatters were introduced in the United States. But they only left there for about 2 years. Why? Technology was nice in terms of detection, excellent, nice pictures. The problem was, it was like naked pictures. So you could see full body details, you could see everything what you want, but also what you don't want to see. So for these two reasons, excellent in detection, excellent in security, but for two reasons, privacy and health concerns, the backscatter quickly disappeared. And then the door was open for millimeter wave screening. With the precondition that no raw images, no clear pictures. So we have to use avatars. And that was the time then for AI, because this means we need automatic detection, automatic target detection, to show where on the body, on this person is the anomaly and match this position on the avatar position. So, and that's how the journey started. Meanwhile, we have 10 years, the system in operation, and AI definitely is the key to constantly evolve and develop the body scanners with the needs in aviation security, in terms of detection, but also in terms of reducing false alarm rates, makes the journey more convenient, and also to utilize the capabilities of millimeter wave. We can detect nearly any material, nearly any kind of objects. But with specific training for specific application, we can utilize this capabilities also for very different applications. If you want to protect a data center, you don't need the same capabilities as if you are on an airport. Here we want to see data peering devices, SD cards, USB sticks. No one in aviation security is interested in these things. So AI is definitely the key, which helps us here to, let's say, build application-specific and constantly evolve here the scanner solutions to what is needed.
Thank you, Peter. Adan, SeeTrue stands out for application in AI in automatic inspections. How do you have your solutions help to increase security screening and optimize operations in these critical environments?
Okay, so what SeeTrue does is uses AI, in fact, to improve and enhance screening on X-ray and CT machines, right? Now, I want to talk about the benefit of AI from the human side of things, right? An X-ray operator, the person, the lady or the guy who's sitting behind the X-ray, it's a very boring job. It's a very repetitive job. When you cross in the airport, you go through the X-ray and you see the person sitting behind the X-ray, they mostly look very, very bored, right? And at the same time, they have a very difficult job because they are the last line of defense against a bomb going on board a plane. So this job can be improved, can be enhanced through the use of AI, and that's exactly what we do. So we look either together with the agent on the image and help the person to interpret what is there are prohibited items, is there are threat items in the image, or in some cases, we actually can replace the agent, and I will talk about it maybe later. But that's the benefit that we can do. Now, so I'm looking at the AI from the angle of the human weaknesses, right? So we overcome that weaknesses. We are never, the software is never tired, the software is never sick, the software doesn't have moods, right? And it overall increases and enhances the security process. Now, there are other things, right? You mentioned 9/11, right? Threats evolved. If before that we were thinking about a bomb the way that we saw sometimes in Tom and Jerry's cartoons, you know, a round ball with some fire cord. So we had the underwear bomber, we had the shoe bomber, so threats evolved. When they do, and you want to train your operators on it, and sometimes you have thousands of screeners at the airport, it takes a very, very long time, and not all of them can learn a new threat and how to detect that. Much faster, much more efficient to train a software to do the same detection of a new threat, right? So I can train the software in 2 weeks to detect a new item, whether it's that bottle or that glass, and deploy it across all the airports. So that's another benefit. And the last benefit I want to talk about is the insider threat, right? The person sitting behind the X-ray and is supposed to stop a bomb or a gun or a knife going into a prison or going into the airport can also collaborate with the perpetrators. They can also be the ones who are getting paid and saying, ignoring a knife going into a prison, and later somebody else will be stabbed. So the software, again, cannot be bought off. And so it overall improves the security process.
Thank you. Daoíz, Mion Technologies is recognized to develop innovative sensors for detection of narcotics and explosives. What are the main technologies innovations and differentiate these sensors from the previous solution that we have?
Yes, thank you, Paulo. What we develop is vapor detection systems. Vapor detection system is different from the traditional existing technologies, mostly based on vision system. And in few words, this can be defined as the evolution of the dogs. As my colleague said, dogs typically are sick. They don't work every day as the previous day. So what we do is to try to replace them using technology. This technology is much sensitive, and this technology works every day. This is similar to the concept of the software presented by Adam. So what we do is a new technology. This technology perhaps is not or don't want to replace existing technologies. In my opinion, this will complement, because in some cases the security of the future is not a very big system with a lot of capabilities. It's the combination of technologies. And also very related with the colleagues said about the new threats. Perhaps not in the explosive case, but in the narcotics. One of the priorities of the European agencies is the new synthetic drugs. With the drugs, with the traditional technologies, it's very difficult to detect and also identify new drugs, new precursors, new things are coming to Europe. And with the use of these technologies, molecular technologies, detection by the molecular analysis of the vapors, we can determine new substances very easy. And this is done using artificial intelligence. When we have a new sample of a new drug or a new thing that we suspicious that this is something problematic, by the analysis of the patterns, the patterns of these new substances, we can determine that this is the spectra, and we can include it in the database very easy. We don't need a very difficult chemical analysis. So this is what we do, is a new concept of detection that can be complement the existing technologies.
Peter, in your case, the body scanners are already approved to use in airports. The regulation is also an issue. In case, I think SeeTrue and Mion Technologies is working on this. Can you share with us this, what are involved in this regulation and to achieve to these improvements? And also, can you share us your idea about integration of these kind of equipments in, let's say, a central system that manage and facilitate the operations in an environment like, for instance, the civil aviation?
Yeah. First of all, yes, aviation security is comparably easy, as it is a regulated market. So we have ECAC standard, we have TSA standards, we have CAAC and other authorities approving or setting the standards for aviation security, plus nationalization of standards, or on top of that, sometimes national standards apply. The standards are not fixed, so also ECAC developed, we are 2.1. US is discussing tier 1, up to tier 4. We are actually the only supplier who is able to meet tier 4 standards in US. And how to achieve this, we work very closely with these entities together. I mean, they cannot tell us, and they will not tell us exactly what are the kind of threats, what is the testing methods, but they tell us in general what we have to do. And then we go in testing. We are working very closely with the federal German police in this respect, sending them our new detection models, which we evolve, and get a feedback, okay, this works or this doesn't work. This includes scenarios, as you said, the shoe bomber scenario, the Detroit scenario with the underwear bomber. These are regulation or requirements which have implemented now in our software, as this was requested by TSA, by national regulations, not by ECAC itself. So, but coming back on a more general view, because it also touches the non-aviation market, for the first years we have just used AI to enhance the detection of our scanners. Once we have achieved ECAC 2.1 standard, all progress we have in our algorithms, in new graphic cards, more computing power, is to bring down false alarm rate, to make the system more effective and the whole journey more convenient. No one wants to queue up and get an unnecessary touchdown. And this takes the next step. Then actually what we are doing is enhancing the periphery of the system. So we have now embedded shoe scanner. You have maybe heard or seen on the internet, or if you look on TSA checkpoint Las Vegas, you can Google this. There you see auto scan, which allows the people for self-positioning in the scanner with automatic triggering of the scan. So no operator is needed here. That's what you said. We have to release the operators from routine working, which has nothing to do with security. We have integrated gates so that they have automatic access control to the system. You can combine this with biometric access or with access control card. And this idea put us to the point that we joined up with eShelter, with Sentry, and built up what we call a human-centric security lab in Berlin, where we have the complete security process, fully integrated in a holistic security approach, fully digitalized, what is say the IoTization of such a process. So it goes from identity verification, biometric identity verification, gates, security gates, the cameras, you have the perimeter protection, you have e-lockers, you have our scanners, it goes down to an individual rack you can open with your access control card, all connected and integrated in the centralized security operations center. And that's the common understanding of holistic, fully integrated security. What makes our idea a little bit different is that we put the human in the center. We want to make the journey as fast, as comfortable, and as less insulting as possible. To overcome the human factor, mitigate the fatigue of security operator, release him from unnecessary burdens. Consider a data center, you have to protect, you have to guard them 24/7, 365 days, the entry into the server room. And that's the worst job on life. You have very few people going in, going out. It's dark, it's loud, not a nice place to work. If you can release security from this job and make this process more automatic, supervised from an operation center, that takes a lot of burden away from the operators itself. It saves cost, it overcomes the problem of getting staff on the market, which is a big problem now. On the same hand, we can enhance security in total because we not only have the individual devices as your X-ray, as my body scanner, but we combine the information of all of the integrated of the components. The camera system, the access control system, the verification system, the scanner, the X-ray, and we have a full digital twin of the entire process. And that is a big game changer here. Not only in terms of having a complete picture of security situation, but also in terms of access to big data we generate with this, to optimize your process, to control your processes. Also in case of incident, the reporting, what happened, at which point. Yeah? Today, with isolated system, you have problems to cover this.
Same question to you, Adam. You have the experience to interface with another systems because your system is agnostic to the X-ray machines. So you use the data from X-ray machines to integrate in your system in order to provide AI analysis of these images. So you can share also some of your experience on this. But also, what I want to also to explore a little bit is this view of integration of several systems, because sometimes we are focused in the application of AI to a specific sensor, but not to collect all the information of several sensors in order to have let's say, a general idea what is the threat. Sometimes it passed 1, past 2, past 3, but if we look the information of all, maybe it don't pass.
True. One of the threats and the challenges of cabin baggage searches is that you could have potentially a few terrorists boarding the same flight, and each of them is taking one component of a threat, right? So you can have one, even a gun, you can break it into 3, 4 pieces, and one will have the body, the other one will the barrel, and one will carry the bullets. And so we focus on the detection of the individual items, first of all, so that we can not only say, well, we can detect a gun, but we can detect a part of a gun. So that addresses one of the issues. You also said correctly, we're agnostic to the type of X-ray or CT, which is an advantage for the user, because we have, for example, clients that have several types of machines, different manufacturers, but they put our layer of software on all of them and actually get the same results, right? So the same detection level on all 3 types. Eventually what you want to do is you want to see the holistic approach, you want to see the overall sensors coming together, whether it's the X-ray, the body scanners, CCTV, passport control even, combine all that into one process, right? That's a huge challenge, right? It's what everybody wants, but it's not an easy task. There's always when you try to create collaboration in a market which is run by commercial entities and commercial companies that have their own interests, they don't necessarily want to collaborate and share revenue with you, right? So me and my colleague here, we could be very good friends, but if he sells something that will, I'm not going to profit from it, so the collaboration will not be very, very collaborative. So yes, we want to get there. Everybody wants to have this total integration. I think we're making slowly progress in that direction. The industry is working very hard on creating an open architecture. If before that we had challenges from the manufacturers, they are now basically forced to create an open architecture so that third-party algorithm providers like us can integrate and provide value, but also extract data that can be used in an integrated system.
Daoíz, more or less the same question to you. I know that the system is very new. You are starting putting these sensors in the market. But how do you see the integration of these sensors and that information that you detect in let's say, other systems of systems pre-existing? For instance, your system is applied to customers, for instance, for detection of narcotics. So maybe this is good to have integration with logistic platforms that already have existing. So do you think that these open architectures and open APIs, in order to integrate that information and integrate information from several sensors in order to apply over this data, another layer of artificial intelligence will be, let's say, the vector, the pointing, and what we need in the future?
Yes, as Adam said, integration is always a challenge. And depending on the scenario, the challenge is different. For example, in the aviation security, the challenge is challenges are ones, and in the market of the customs, the challenges are others. So the first challenge is the interoperability and the integration of the data. So this is for us difficult, just to integrate something or the results of the instrument or the information we need for the analysis is a challenge, because in some cases some information is technically in some formats that it is not compatible with our system. But this is, in my opinion, something that we can solve from the technical point of view. This is a lot of solutions, and in this case, the use of artificial intelligence to create algorithm for the interoperability is something feasible. My main challenge, or the challenge I identify as a major challenge, is the time. We need to adapt your time you have for the analysis with the time of the logistics. If you have a container for 2 hours, you need to do something in 2 hours. But sometimes the time is minutes. So this is a challenge. You need to adapt. You can develop the best technology in the world, but if the analysis in terms of detection lasts 2 hours, it is not operative. Say goodbye, because no one in the world is going to implement this in your facilities. So the challenge I see, what we are experimenting now in collaboration with many customs around the world is the time. They need the results just in time. The integration of the result in the final protocols in the existing system is something that we can work on this, but the time is an issue.
Peter, can you give us, let's say, an idea of the future that we see with Rohde Schwarz evolution in these sensors? Just, let's say, in 5 years, what we should see.
Okay. Yeah, future. You remember the year 2084, when Arnold Schwarzenegger traveled to Mars, and then he passed security, and this was a walkthrough security screening. And so Rohde Schwarz, we brought the future 2084 down to 2024. So we already have this walkthrough solution on the market. The first of its kind is approved for aviation security and stands in Frankfurt, so you can walk through as a normal passenger going on your flight. Since years, we have this walkthrough solution in operation for VIP screening, Munich Security Conference, high level, but also protecting critical infrastructure, nuclear power plants, Parliament, German Federal Parliament will get these scanners soon, as the Netherlands Parliament. So at that point, the future already starts. We're using the same technology also to go into other applications. We use the millimeter wave sensor to screen into packages, not with a camera, not with X-ray, but with millimeter wave. For example, to detect if in a package of pills it's empty, or in logistic distribution with Amazon, is in the package, is the iPhone really in the package, or it's just a stone? And things like that you can also utilize with the millimeter wave scanners. We call this imager product. And same, we're using the technology to test and simulate the radar sensors on the automotive, because it's the same frequency range, the same kind of technology. So we have a wide number of products already in this area. You see, we can utilize this technology and also the AI behind for different applications. Now, other things we developing in future or already. I talked about the AutoScan, the integrated shoe scanner, but the big challenge in AI-based detection models is training. Yeah? You need a lot of training data. We collected training data now since more than 10 years. We have some 5 petabyte on data in our own data center at Rohde Schwarz, and we are constantly doing this training. But in people screening, it's a little bit more difficult or challenging, as it might be with X-ray. I don't want to make your things too easy, but I know how complicated it is with us. The way we train today is you have to go with working students or with your own people, equip them with the object of interest, and then you have to make images, reconstruct the images, hundreds, thousands of images, you have to label them, and then you put these data in the deep learning pipeline, supervised learning. So you need a lot of resources, you need a lot of time today to, let's say, adopt new objects of interest, or to constantly develop and continue with the the threats. So we today carefully select what we are doing and what we want to. We cannot, theoretically we could, but if a client comes to us from loss prevention, can you please detect this or that? We say, okay, is it worth to invest the money and the resources in adopting to this? In future, we want to simulate this kind of data. And that's a big challenge, yeah. You have to simulate the body, and that's the most challenging part. So how is the body looking like in a simulated way? Must look the same way, three-dimensional, as it looks in our scanner. And we have built up a new company called 5D. It's a spin-off of the university in Erlangen, and with Rohde Schwarz. And we are doing exactly this here, looking into radar simulation. And then to simulate the body and then to simulate the object for training so that we can generate this training data artificially. And that will definitely boost if we have these capabilities and in the respective quality we need, then this will definitely boost the capabilities and make it even way more easier, as you say, maybe in 2 weeks to develop a new algorithm also for body screening. Yeah.
Adan, some question to you, but because you are most focused in just artificial intelligence, also can you give us your idea about the role of human operators and AI? How can you see the evolution of AI and your type of equipments and systems? Also, how can evolve the operation and what is the role of humans in this?
So I always say, let humans do what they're good at and let artificial intelligence do what that is good at, right? So that combination or that convergence of AI and humans will always exist, right? We're not going to get rid of humans. We're going to have humans using AI in order to do a certain process better. So I don't see AI replacing necessarily people in the security operation, but there will be a shift, for sure. And you can see it already happening now. Next week or the week after, we're installing our system in Schiphol Airport, where the system was approved by the Dutch government, and it allows for some of the bags that do not generate any alarm to completely go without showing that image to a human operator, right? So the future is today. So we're already having a system that can scan, use AI, and take the decision that that bag is clear and does not even show it to an operator. So just imagine when you go in the airport, you usually have 2 trays where you put your trolley in there, and in the other one you put your jacket and your keys and your telephone. Does a live operator, a human operator, really needs to look at that bag, at that tray with your bag and keys and phone? Software can easily clear that. So 1 out of the 2 trays already will be cleared automatically. And that's happening. That's happening right now. Another thing that this will help is that the humans nowadays in most airports are sitting behind the X-ray. Very noisy environment, a lot of distractions, passengers coming in and passenger talking, and you have other colleagues there. We see this trend of moving into a centralized screening location, which is much more quiet, remote location, a closed room where only people that are watching the X-ray images are sitting, right? So once you've done that and you moved your operators behind the X-ray into a remote screening, and they can focus on the images themselves, and you send all the images from the X-rays, the different lanes, into that remote location, and you, at the same time, minimize the amount of images being sent to them because the AI is clearing that. So you can reduce the number of people. You can have your best screeners in there. So, get rid of the ones that are not so good. Today you cannot, because you need every single person in there because there's always shortage of people. There's not enough screeners. So now you can focus on having your best screeners at that room, looking mostly at images that have generated alerts, right? So you might have, you know, if I look into the future, I might have a situation where I have a multi-layer, multi-tiered approach of screeners where some screeners, if I generate an alert for a sharp object, I'll send it to an operator which is specialist in sharp objects to decide what it is. I could have another one who's very good at recognizing IEDs, right? So that image will automatically go to an agent which recognizes best IEDs and explosives and can, you know, look at it. So again, humans will be there in the process, but they'll be utilized or will be optimized, used thanks to AI.
Daoíz, regarding your sensors, can you give also a perspective of future? What do you see in the evolution of this type of sensors, not only in customers, but also in civil aviation, in loading things? Can you give us?
Yes, in my opinion, and as I said before, the future of the screening solutions is the combination of technology. It's similar, as Adan said, about the multi-layer system where you can detect, because it is a reality that the budget of research for the narco, for the mafia, for the terrorists is higher than the budget of research for the companies. So they are always ahead. When we think that we are able to detect everything, they invent a new method. In the case of customs, one of the priorities of the Europol, for example, is the chemical concealment. In Spanish, they say that mezclados. They mix the drugs with minerals, with other things, which is totally invisible for X-rays. So this is why I said that the combination of technologies is the future, in my opinion, because some threats are not possible to detect by sensor, like me, molecular sensors, but other threats is not possible to detect by vision sensors. So, and there is a challenge here, because if we want to combine technologies, the integration is a real challenge. So only the integration of artificial intelligence in one sensor, as my colleague said, is difficult. So if we want to integrate things, totally different technologies in one system is difficult. But I believe that the combination of technologies is the future.
Thank you. So what the main, we are coming to the end of this discussion. What we propose to do is to continue this discussion, because we have your systems in exposition, in the exhibition. And what the purpose of this is just to open the discussion of AI and IoT in two different layers. One layer is in the edge of IoT, and what is the role of artificial intelligence running on the edge of the IoT, and what another layer is to combining information of all sensors from several sensors in order to provide another layer of artificial intelligence in order to, let's say, bring more information for human decision. This is more or less what we try to explain in this conversation. And thank you all for your insights. And I invite everyone to, in the exhibition, continue this conversation with the speakers. Thank you.